Hi, everyone. Thank you, everyone, for joining us today. I'm Bing Pen, Product Marketing Manager at Mapbox. This is a 25-minute session. It's all about Mapbox Offline Search. Before we get started, I have a couple of housekeeping items. The, this session will be recorded and will be available to all people who signed up. Captions are available in multiple languages. You will see on the right hand the screenshot. Please submit your questions through Zoom Q&A features. We will try to get through them. Lastly, if you want to discuss more build sessions, go into the Zoom lobby. You will see all of them. All right, let's get to good stuff. I'm very excited to have some of our search members today with us. They are Jordan Palmer, Engineer Manager for Search, and Ahmed Ali, Software Engineer for Search as well. With that, Jordan, let me hand it over to you to kick things off. Thank you, Jordan.
Hey, thank you. Good day and welcome. Like Bing said, my name is Jordan Palmer, and I'm Engineering Manager of Search. And I'm joined today with Ahmed Ali, who's going to be our lead engineer for Offline Search. And today we're going to explore a topic that is important to navigation application development, which is building for an offline experience. Specifically, we'll be looking at the Mapbox Offline Search SDK. So we're going to talk about what is it, what are some of the key use cases, best practices, and then Ahmed's going to walk us through a demo. Okay, next slide. Briefly, want to talk about some of the other products in our search portfolio. So we've got 4 different products. We've got our geocoding API, which allows us to perform forward and reverse searches, which we'll talk about a little bit later on in this talk. We have our address autofill SDK, which is if you have an order form and a user is typing in an address, it's a way to autofill that form, and the user gets a nice map and a pin that they can move around to verify their location. We have our search box API, which is a premium search feature, which is an enhancement to our geocoding API that adds POI or point of interest search, including categories, brands, and landmarks. And then finally, we have our boundaries product, which is a comprehensive data set of administrative, postal, and statistical borders globally, and it's used for visualization, geofencing, and all kinds of different use cases in that way. Okay, next slide. Okay, but let's dig into what is Mapbox Offline Search. So when we're building on-the-go applications, you cannot always assume connectivity. So like consider if you're like a driver going through a national like remote park, or you're an EV owner in an underground parking garage and you're looking for the nearest charger or charging station, or you're like a logistics worker in a massive warehouse where the Wi-Fi is spotty. In these moments, an application that gracefully handles a loss of connectivity can be really essential. So thinking about your application's offline support is important for a premium user experience. This is especially true in industries like automotive and logistics, where you don't want to have your core functionality contingent on a weak cell signal. So for these, offline really needs to be a very core business strategy that you're thinking about. And so Mapbox, we've built a suite from the ground up with offline in mind, and the ability to switch back and forth between connected and disconnected situations. Next slide, please. So key use cases. So the biggest use cases to think about is when either connectivity is unreliable or it's completely unavailable. And it might be unavailable on purpose. Like you might be creating a device or a vehicle that once it rolls off the factory lot, you never plan for it to be connected at all. So here's got some of the top use cases that we think about, but there's many others. So automotive and e-bikes. So these are where we're working with in-car navigation systems that must keep working in all kinds of different environments where connectivity might be a problem. So think about, tunnels or rural areas, or they're just going to be offline completely. Fleet and logistics. So this is where you have like delivery drivers or ambulance crews or service technicians that, their services are really critical. And so whenever they travel through like network dead zones, you don't want that to get in the way of them being able to, get where they need to go or to find landmarks that they need to look for. This can also be really useful in like a dense urban area where you have like a high sky rise, and that can sometimes interfere with connectivity. There's also outdoor recreation and tourism. So here you have hikers, cyclists, campers that frequently go into areas where there's just no cell coverage at all. And this would allow users to still find, trailheads or campsites or emergency services if they need it. And finally, EV chargers. If you own an EV vehicle, um, you might have some anxiety about trying to find the nearest charger if you're planning like a road trip or you're getting a little low on your charge. And so this gives you a lot more confidence being able to make that search if you're in an area where reception happens to be poor. And there are many other use cases, but these are some of the standout ones that we work with all the time. Okay, next slide. So what's included with the offline search SDK? So most of the operations that are available with our online search are available offline as well. So the ones that we typically think about are forward and reverse searches for both address and point of interest or POI data. So if you're not familiar with those terms, forward geocoding is whenever you have like some sort of text query. So that might be like an address or the name of a POI, and you want to be able to find those records and get additional metadata and coordinate data about it. Reverse geocoding is the opposite. This is where you have a coordinate, let's say maybe like the user's position, and you want to be able to find whatever is there. So let's say that you're using like a family tracker app and you want to see where your kids are, and you could use their location to go, oh, okay, my son is at the mall right now, something like that. So that's a reverse geocoding use case. We also support search along the route. So if you're using our navigation APIs, and let's say that you're traveling between city A to city B, search along the route would be really useful where you say, hey, I want to be able to stop and grab a coffee, or I need to, go to the bathroom and have a stop. And so you can add different waypoints along your route, and that's also available offline. So all of these can be done without a network connection for a large portion of the world. Now, in terms of coverage, offline search can be configured with any of the different countries and languages available for our online API. So we often work with customers to create, bespoke tile packs that contain, the countries or language coverage that's really relevant to their user base. So for some people, that might be just kind of what we offer out of our stock set, or it might be something that we configure. Now, in terms of limitations, one of the challenges with offline data is storage. So Mapbox offers several different offline solutions. We have our maps data, navigation, and search. So how much of the offline experience you use will depend upon the amount of on-device storage space that's available. So to optimize storage space for search at least, only the minimum amount of like metadata or attributes are going to be stored in the offline cache. So this will mostly be like POI name, address, category, and coordinates. Other rich attributes such as like business hours, phone numbers, user reviews, or like live data. So like let's say you're pulling in parking data and you want to know like parking availability or charger data. Some of that stuff is all reserved for the online experience. And that's really just to help us minimize how much data we're putting into the offline storage. One more feature that's also reserved for online is brand search. So that has an extensive brand database. And what that looks like in offline is that well, actually, let me say it this way. In online, when I do a brand search, I will get a first response back and I can interact with it. And then I can get a full list of every POI that's like linked to that brand. For offline, it's a little bit more basic where it's doing a text search. So if I do a search for Starbucks, instead of getting that full brand back, I'm just going to get, all of the records that have Starbucks in the text name. Okay, next slide, please. Okay, key components. So let's start with just kind of here's like all of the things that make this work. So we have the offline search engine, which is the API surface that you call. We have a set of tile set descriptors. So these are what give metadata that describe what is in each of the tile sets. So for the addresses, POI, or places, or other things if you're using some of the other offline capabilities. Tile regions define the geographic area that you want to cover. And then finally, we have the tile store, which manages the downloads and the actual storage itself of everything that's available offline. So what you do is you install the SDK, you download the tiles for your region, and then you're essentially ready to search. And everything happens locally against a local index that's on device. So no network calls have to be made once everything's loaded on the device. Now the tile store is where it all comes together. So think of it as like an on-device database that holds maps, routing, and search data in one place. And because our maps, navigation, and search SDKs all use the same tile store, the data stays consistent. That means if you download a region, the roads you route on, the POIs you search for, and the map tiles you see, they all come from the same place. So there's no duplicates or out of sync results. Okay, next slide. Okay, and I'll just briefly talk on this. So here are the different strategies for loading the data on the device or offline. So the first strategy is developer-defined regions. So this is where you build into your application some sort of user action that explicitly downloads data for a specific geographic area. So think about it like, let's say you have an app where a user is preparing for a trip, and you could say, they could say, hey, I'm going to click this and then download that trip offline into the app, maybe for like a city or like a national park they're visiting. And that's initiated via the SDK API. You want that to be fairly, restricted to a small area. You wouldn't want to do like a whole continent, but you can drive it that way. The second option is a preloaded tile pack. This is also known as like a factory install. So this is what we do when we have really large scale industrial deployments. So think about like the automotive industry where we're going to have a massive fleet of cars that are rolling out to a really large surface of different countries. And so we're going to have a lot of continents that are installed on the vehicle's head unit at the factory or the dealership. Usually we'll have like some sort of USB drive that we load that from. And so this ensures that all of the offline map, navigation, and search functionality is available for the entire life of the vehicle. And then third, we have what's called predictive caching. And so this is where the SDK works intelligently in the background to automatically and preemptively download data. And so whenever you're using the navigation to plot routes, your current location or your destination, it's kind of like as it gets connectivity, if you have that, it will automatically start downloading where it thinks you're going to be. And then that way, when you go offline, you've got kind of like a cache that's been loaded in already, and it can cover you whenever you don't have any more connection. All right, next slide. With that, I'm going to turn it over to Ahmed, who's going to give us our demo.
Hello everyone, my name is Ahmed Ali, and today I will be giving a demo of how offline search works, and I will be doing a live demo. So uh, the first part of my demo, I will be sharing my whole IDE because I would like to show some logs of predictive cache in action where it will be downloading tiles. So now I'm just starting the app from scratch, and I set my location to a Disneyland in Los Angeles. So let's start the app. It will just take a few seconds. And so predictive cache is basically something that developer can configure it once, and it will just work automatically as a user is changing location and navigating and so on. So once the app starts, the first thing it will do, it will start downloading the required tiles to cover the current location. So this will happen immediately once the app starts, and you will see that in the logs here. So the app is starting now. Uh, and you can see it immediately downloaded two tiles, so these two tiles are downloaded now, which are required to do offline search. Currently, I'm online. So what I'm going to do is I'm going to turn off my Wi-Fi. Uh, so now I'm completely offline. I will just do a quick search using like cafe here, for example, and you can see it is working pretty fast, and I'm getting many cafes around my location. So another thing I want to show in if using predictive cache, I will turn on Wi-Fi again, and Now I will just change my current location. So let's clear also the logs here. And in the background, I will be changing the emulator location to San Francisco. So let me do that. And you can see it started downloading another tile right now, which happened immediately, which covers because I moved to a far area, so we need more data to cover this. And since I was online, downloaded this tile. Um, and let's turn off Wi-Fi so that we can test it again in San Francisco area. And let's just restart the app now. This will take like a minute or so.
One thing, Ahmed, while we're waiting for this, that I'm thinking about is that some people will usually ask about how do I switch back and forth between offline and online? Like, what's a good strategy for that? The SDK itself doesn't support that behavior, but you can essentially like follow a workflow to implement it fairly easily, where depending on what you're wanting to do, if you're wanting to have like an offline first or an online first strategy, our API allows you to kind of check for the connectivity, and you can either say, okay, if I'm connected to the internet, then I'll try to make an online call, or you can, if you don't want to make a whole lot of online calls, you can do it the other way around where you use offline by default, and then if the user happens to be online, then you just get, richer data back that's added to the result.
Okay, sounds good. Now the app is up and I still don't have connection. So let's search for a cafe. Now it is showing it's still, I'm completely offline now and it's showing cafes around my current location in San Francisco. And one more thing. So what predictive cache was doing right now, it was just downloading the required tiles around my current location. So let's try to navigate to somewhere far away. So let's try uh, uh, to navigate to Disneyland, sorry, which is far away from me. I don't know what- So it's, so let's navigate to like somewhere far away, and this means uh, you can see the route is across the whole California, and predictive cache started immediately downloading additional tiles which cover the whole route. So during my whole route, if I go offline for any reason, uh, it will still offline search will still work. Uh, so now, during the remaining part of the demo, I will just focus on the emulator. I now have shown how the predictive cache works, and it downloads current location and tiles around my route. So I will just share the emulator now for the rest of the demo. So now we can see just the emulator without the logs. So now let's show some of the offline search features. You, let's turn off offline the internet because for the rest of the demo I will be completely offline. Um, so with offline search, we can do a category search. Here we have some quick buttons like coffee. We get some coffee shops around my location, restaurants, gas station, and we have hundreds of categories we can search for. Parking lots, for example, here I can see parking lots around me. And if, for example, I want to search for a category which is not, we don't have a button, for example, I want to find a beach. So here it is showing all beaches around me. Uh, and we can also do like, besides uh, category search, we can do places search, which is like searching for a city. For example, now I'm searching for Los Angeles. I'm getting the city as the top result. Um, And we can also do like address search. So let's search for an address. This address, I'm getting the results very quickly for that address. And also offline search supports mistakes in the query. So let's try like the same address search, but with the M missing. So here I'm missing the second character. Uh, sorry. Yeah, still I'm missing the second character, which is the M. I'm getting still the same results. And we can also search by like brand name. It is not doing actual brand search, but it will still show like uh, POIs around me with that name. So now I'm searching for Starbucks. It is showing all Starbucks around me. And again, it can allow for mistakes in the query. So let's try without the S at the beginning. I'm still getting Starbucks results. And let's like make a mistake in the middle, not without the B. So I'm still getting Starbucks. Uh, and one more thing about category search is that we can do it in other languages. So uh, it does work in many languages, and this works with any data set you have. So this works by default with any data set you download. You can do just it is just for category search. It is what works with any data set. So for example, if we type this, which is I think a parking, but in German, I'm still getting parking lots. Um, and let's try a few more languages, uh, some Latin and some non-Latin, and I will do also uh, uh, something like Japanese. And you can see these all mean parking in different languages, and it is still giving me uh, the parking lots around me very quickly. So if I hit search, you can see the query and the parking lots around me. And let's try Japanese. Again, it's still giving the same parking lots. I'm searching in Japanese now, even though I didn't download any Japanese specific data set. It's still giving me parking lots. Uh, and one more feature in offline search, which is EV search. This is also a category search, but we do like special additional information for EV station, like the level, the max power, and you can also in your EV search you can filter by many parameters like brand. So brand search we have more additional functionality for brand search. Uh, yeah, I think that is pretty much it uh, for my demo, and we'll. I don't know if we have a few minutes left for questions, but I will give it back to Bing.
Thank you, Amanda. This is awesome. Thank you. I thought we have a couple of great questions. We have a couple minutes left. Let's get started. Jordan, I think you might be able to answer this one. How can I use offline search? How do I work with offline search through SDK?
Yeah, actually, Ahmed, do you want to describe a little bit about how offline search works in terms of setting it up?
Yeah, sure. So the first thing you do is you need to configure how offline search tiles get downloaded. So either by an offline tile pack, which is already built in on device, but for programmatic way, you can let the user, for example, select an area and you make a call to download that area. But our favorite method is predictive cache, which is just works automatically, where you will just set radius for current location and for destination and for around the route, and it will just work completely automatically, downloading the tiles as you move. And to do that, once the tiles are downloaded, you will just provide the tile store instance, which is our database for the downloaded tiles, to our offline search engine in the search SDK. and just perform offline search and it will work. And something Jordan talked about is just like maybe in your logic, you can check for connectivity first. If there is internet connectivity, you do online search, otherwise, you do offline search. So this is a quick overview of how to do it.
Awesome. Thank you, Ahmed. Another question, how is offline data refreshed? Like, what is the offline data refresh life cycle for users?
Okay, I can get this as well. So on our end, we try to update our data every week. So the data sets will be updated every week. But it is also this is something you can discuss with sales team if you want something less frequently or more frequently. We can do that. But for the already downloaded tiles, they will work as long as you still have them. They will not like go away. They will just keep working until you either delete them or update them. But from our end, we update it weekly.
Awesome. All right, thank you, everyone. I thought we have a couple questions we could not answer live. We will be following up with you guys, provide some answers. But thank you, Ahmed, thank you, Jordan, thank you, everyone, for joining us today. Thank you.